Hi, this is Jeff Heaton. Okay, in this video we're going to try something very different. So I've been showing you how to make use of my Kaggle utilities. So now we're going to look at how to apply those utilities to a live Kaggle that is currently going on, at least as of the recording of this video. I'm referring to the Santander Bank customer transaction competition that is currently running on Kaggle. So I spent the weekend looking around at the competition, understanding it. It's well underway. It's got about 24 days left at this point, so it's a bit late in the game, but it serves as a good example for how to apply these tools. And I have not really competed in a Kaggle in about a year, so this will be a good chance to apply these and to show you how to use this on an actual live Kaggle that is running. All the code is currently on GitHub. So let me know, do you find this kind of thing interesting? Would you like me to continue with this Kaggle competition and post some video here? Or perhaps take on a Kaggle earlier in the competition? Again, I saw this one after it had already run for well over half of its lifetime. But it's a good example. I'm not sure 100% if I will enter it yet or not. I probably will. And of course, if you find this kind of thing interesting, please subscribe to my channel and click the little bell so that you're notified of any additional videos that I create. So let me know if this kind of thing is interesting. Would you like to see me take on live Kaggles and give you some updates as I go through? I can share models and other things that I do. Okay, here is the main page for the Santander customer transaction prediction. What you're essentially trying to do is take some data that they give you and predict if that customer engages in a certain transaction or not. First thing that I like to do when I go into any Kaggle is just look at how far along the Kaggle is. It's got 6,167 teams and 23 days to go. This is a mature Kaggle competition. It is well underway. But there is some time potentially to do something with it. So I'm not sure that I will actually make a submission yet, but I'm going to look into this a little bit deeper. I'll get into what I've done with this so far, just playing with this over the weekend, and what I would probably do next on this one, and will do next. The next thing I like to look at is the leaderboard. The leaderboard in this one is very interesting. So this is being evaluated with something called an AUC. Area under the curve. What is a little different about AUC than a lot of the other error metrics is high is good. You don't want to try to get lower and lower. 1.0 is perfect. So the people here at the top, the teams, they've done really quite well. They pushed this well into the 90s. It would be very difficult, I would think anyway, to push this too much beyond this without overfitting, which the final holdout set is supposed to prevent. So we'll see how high this actually goes. Now, as you scroll down, the other thing to be aware of on a Kaggle is the green means in the money. These people would win money if they can maintain their spots for the next couple of weeks. The gold medal is very good, 1 gold and 2 silver, and you are a Kaggle master, something I have not yet done. And then silver. Now notice what's really interesting here. 90.901. And then there's just this gigantic group of these guys. It goes on through the gold, into the silver, and well through the bronze. If you go into the kernels, so these are the kernels. This is code that people have given you to help with your own Kaggle. I make use of this code quite a bit, as you always got to keep aware of the other features that other people are discovering and other things, because you need to incorporate that into your own modeling. Otherwise, you'll just be at a disadvantage to everybody else that is incorporating them. So if we look at this, notice this area right here. 0.9. That is the score that this model has given you. You can submit right from here. So basically just click the button and you have a 0.90. That's why there's so many 0.90s. That's why the same score in this competition literally goes from that wide of a range. So from 0.90, it's not too hard to get to that particular score. We'll see that one of my models that I'm working on ensembling actually gets to that really relatively easily using like GBM. Now let's look at the data. The data, and I'll show you this actual file in Excel in a moment, but it's 200K rows by 200 features. And if you look at the training set itself, this is one of these highly anonymized, redacted Kaggle competitions. The variables are all named var 0 through 199. I don't like these as well because you just can't apply any real-world smarts. So this is pure machine learning programming, which is fine. I've done, of the Kaggle competitions that I've scored the highest in, the Quora one was you knew exactly. It's 2 questions and you determine if they're just asking the same thing. And then Auto Group Challenge, the other one that I did, top 10% in, that one was like this, completely anonymized. So then the other thing you want to take a look at is have a look at the discussion areas. I always read through these before I get serious about any Kaggle, especially if it's been going on for a while. There's very interesting things, like var 68 might be a date some people are talking about, and there's a lot of interest. You can tell by those numbers there which are the more interesting ones. Just to summarize some of the things that have been coming out of the conversations on this, one is that the variables may be a result of PCA, Principal Component Analysis. So PCA is a way to reduce dimensions. So it could be that the actual Kaggle competition had, the original data set for this Kaggle competition had a larger number of features, and to help redact and anonymize, they ran a PCA on it and reduced it to 200 features. There's people in here who have studied PCA extensively for thesis level education, and they say that the distributions of these features looks very much like PCA. And another just compelling Occam's razor sort of argument for that is exactly 200 features. Usually Kaggle competitions don't have such an even number of features. It'll be 165 features or something like that. So definitely look at the discussions. They will give you some interesting information that may be helpful to you. So now let's have a look at my code for this. I'm using my Kaggle utilities that I've used on the last 3 or so Kaggle competitions that I've worked with. Just go to my GitHub site, search for GitHub Jeff right there. So I'll click on this, Kaggle Utilities. I just checked in right before this video a large amount of updates. So I created an example for the Santander. So I show you how to set everything up to use it. My Kaggle utilities are definitely not meant to be sort of just a package that you pip install. There's some modification that usually goes with it. The big change that I just made that'll make the videos that I've done on this a little bit out of date, but not much. This is a good change though. I broke it into 2 folders. So examples are the examples. So it's not the code that I made that make up these utilities for the ensembling and feature searching and other things. That's all here. So ideally, you shouldn't have to modify JH Kaggle. You've got the examples here, and the examples, you have Mercedes and Santander. Those are the 2 ones that I put together. I'll probably put Auto Group and Quora question pairs. Those are the other 2 Kaggles that I did somewhat well in. Mercedes I actually didn't do that well in, but it was a good test of this utility. And I won't go through this because I've got videos to take you completely through the process. But basically, I set it all up for the Santander one, and that's a good tutorial on how to set your own up as well. Let's go ahead and look at the code. The code is all in VS Code. If you check out my utilities, this is what it basically looks like. There's the examples. There's Santander. There is my package essentially for that. The first thing you'll need to do to set these up is I created a config file. So rather than modifying the code like you did in previous versions, there is a config file. And this is an example one right here. Kaggle config. So there's a config file now, and this is how it was set up for Mercedes, so you can put multiple projects in one. They're not very long. Down here is what I've set up for Santander. The first two is just your ID column. All Kaggle competitions have an ID column. Usually the training test set have the same. It's usually ID or something such as this. As soon as you open up the data file, you'll see that. It's usually the first column. So I just set that to ID column. The goal, actually this is not really used yet, but on this one the goal is not to minimize, it's to maximize. So I'll check that in. None of the tool is making use of that currently, so that won't really bother. But the goal is to get this as high, to get your score as high as possible. Usually you're trying to minimize. The encoding is UTF-8, that's usually always that case. The target name, the fit type is a binary classification. The evaluation is area under the curve. I'm using 5 folds and a seed of 42. Join profiles. Right now I just have one because I don't have many features. I have not engineered any features. This is just using the 200 of them raw. So those are the feature profiles. I'm not doing any balancing or ignoring any columns at this point. I will check this in and it will change as I get more advanced with this Kaggle if I do decide to pursue this one. The path down here in the file, you will have to change that. That refers to this location on my hard drive. Yours will probably be different. Initially, you won't have all this data in here. You're just going to have train, test, and sample solution. You really don't even need sample solution, but these are the 3 files that you will download from Kaggle. The rest of these are all generated by my utilities. Let's take a look at the training data. And here's the training file. You can see the ID code. So that's basically where we got that one field to fill in and target. This is the outcome. You're trying to predict basically 0 and 1. It's a binary class. Then you have the variables 0 all the way up to 199. Everything in this file is numeric. There are no missing values. The other thing you can see just from a quick glance here, although you wouldn't want to do this, you'd want to numerically calculate this, but the data are very unbalanced. I can only see 1 on the screen, one value that is 1. These are the heavily encoded features. They are, I believe they all range with negative numbers, and I have not even looked greatly yet at how normal their distributions are or what their distributions even look like. Like I said, I'm just getting into this Kaggle, more using it as a tool to test out my Kaggle utilities and to make sure that they're adaptable to other ones and that I don't make it too painful to have to go through the code and modify too much stuff. The other thing to be aware of, this did break my utilities from previous. The ID column is non-numeric in this case. It's got the little train and test underbar prepended to it. Now that we've seen the data, let's go ahead and look at how you would basically set up the utilities. So I've got that configuration file. That needs to, and by the way, these utilities run in Windows, Linux, or Mac. You'll want to go to your user directory. So jhkaggleconfig.json, that is the file. That's the file that I was showing you before. One thing to be very aware of is here I don't have a dot because it's just annoying checking in the dot file into here because it'll consider it a hidden file. You need to put a dot in front of it and copy it to your user directory. This is just a sample one. The main thing you're going to have to change is this path. You can also delete out the Mercedes one if you're not doing that one. And it's an old Kaggle competition. Okay, so you'll be working mainly in examples, Santander. You may need to make changes also in my Kaggle. I'm trying to minimize those, but if you have questions or you think you need to change things, post those in the comments on this video because I will be monitoring this and we'll answer things. Here are the tools. So first of all, there's data JTH1. This generates my first set of features. Now the whole thing that I do is I will create data, JTH2, 3, others. Some of these features might take a long time to actually calculate, so I don't want to constantly be recalculating them. I'm creating several feature files. Join will join them together. Then I will use models to train them, and finally Ensemble to ensemble my final set together and submit it to Kaggle. So data, this is a very simple file right now. I'm basically passing through all the columns from 0 to 199. I'm using pass-through. I've got other classes in there as well. I'll probably do a video on data pre-prep. You don't necessarily have to use my utilities to pre-prep it so long as you're creating those files that the joiner can join together. Then I call it and I generate it. So this is my feature batch 1, JTH. That's my initials, Jeff Theodore Heaton. Features that I borrow from other people who have posted those to the kernels, I will give that a different prefix just so that I can tell them apart. Then I run it and generate a report on, there's not much that gets reported at this point because they're pretty simple features. So you run that, that generates these files that it will then load in when you want to join it. So joining is when you create your actual training file, and there's a field in there called fold that determines your cross validations. So if you change the fold count in my config file, you do have to rerun join so that things get rejoined or that the folds get reassigned. Once you've joined them, then it's time to actually do some modeling. Now this takes a long time for these to run. I have set up these XGBoost. Kira's, I think it's basically ready to go, but I have not run that one. I copied it from the previous one. sklearn is good to go. The Ensemble, I have a separate file for that. I'll check this in. So these are really the three that you're dealing with at this point. Now I will add those others. I also want to add CatBoost, which I have not worked with yet. That seems to be popular in this Kaggle competition. You can run them all at once. I tend to comment them out because these run a while. The XGBoost that I ran here, which I'll show you, that ran for 20 hours. So these can take a while. And I'm running this on my laptop. So you would run that. When you run these and they train, that's where these directories are coming from. Don't worry about the blend. We'll get to that in just a second. So the XGBoost that I trained, that when it was finally done, it spit out a folder, and that's XGBoost 0.89. So it's not the best one. The LGB, the light gradient boost, was 0.9. So in these folders are your submit files, and you could actually go into one of these and basically just submit the zip submit file if you wanted to submit that one to Kaggle and be scored on. The next thing that I do is I take all of these and I start trying to ensemble them or blend them together. That's what these two are for. That's in the same file. So these folders are same format. These folders are all basically just models that I've created or ensembles of models that are ready to go. I can use these folders to form ensembles and do analysis on them without having to rerun the model. Some of these models take nearly a day to run, and that can be very time consuming. So look at the models file. You can adjust the hyperparameters and other things on all of these. And I'll be posting other videos on how to work with these tools, components of the tool set specifically. Now we can ensemble. Ensembling is pretty quick, so I'll go ahead and run that. You want to modify up at the top, and this is under the examples folder. So I've kind of separated this so you don't have to modify my original toolkit anymore. I'm trying to keep all the changes going in examples. But these are all of these folder names that I just showed you, and I am going to now ensemble all of these together, and then it'll show you the results. So let me go ahead and just run that. Run the ensembler. It's loading each of those models: XGBoost, Extra Trees, Random Forest, K-Nearest Neighbors, and Light GBM. There's an annoying warning that I need to fix in there. That's fine for now. Here's the blend results. So these sum to 100. And you can see that it's liking the LGB, the light gradient boost, the best, but also giving some weight to XGBoost. Usually this will improve your performance over just single models. It does give you an out-of-sample score. I'm not sure I completely like the way I'm doing the out-of-sample score. I may be improving that some. So that's really just a hint to go by. Because what's unfortunate is the out-of-sample score is a little bit, just a hair lower than my light GB. So light GB alone might be better, or this might be better. You'd almost have to submit it to Kaggle to see, since they're so very close. But either way, the Ensemble does not look like it's giving a tremendous lift here, but it's definitely worth submitting and seeing where it's at. Alright, this was a tutorial on how to basically hook up a new Kaggle, in this case a running Kaggle competition, to my Kaggle utilities. Let me know if you find this kind of thing interesting. Put a like in the likes, or definitely subscribe to my channel if you would like to learn more about these kind of things and others. Thank you for watching this video.